Hello everyone. So this video is really interesting because in this I'll show you how you can feed your own dataset into a CNN model and how you can kind of create your own CNN architecture by feeding your own dataset. Okay, so let's get started with it. So this is code which I modified from the previous code to show you how you can feed your own data. So first let me show you the data which I have chosen. So this one I have kept in the same. This was my working project Keras tutorial. I have kept here. It's not necessary, you can keep it anywhere. So I chose three classes of action just for showing you how to read these files and all. You can in your like real work, uh, depending on number of classes you have, you can have that many set of images. So my first class was bike, and then second class was car, and third class was horses. Okay, so you can either individually read them, or one easier way will be to keep them in one folder. For example, I've kept them in input data folder. Okay, all the compiled by car horses, and when I was creating those individual data set, I just ran a small code to name them. So just like bike 001, bike 002, and so on. So it makes it easier, like, so bike will come first, then car because of the B, C, and then H will come horse. So nothing, this is no big deal, but you can do it for simplicity. And then you create another folder here which is input data resized or anything of your choice, and this folder will contain whatever pre-processing we do in this data, whatever pre-processing we'll do, and we'll save it here, and then from here we'll read it and feed it to the network. Okay, so let me go to the code, and these are the things that we need to import, and each one has some role to play in this network or in this code actually. So this Keras will import the models, a sequential model, will import the dense dropout activation. From convolution portion, will import convolution 2D and max pooling. For optimization, we import SGDRMS. You can import anything. And Keras.utils, NP it is actually used to, what to say, convert your normal class number into some binary format. If it's one, depending on number of class, I'll show you that one. And then you have to import numpy, matplotlib. You have to import your OS, your Theano, and this pil import image. This is actually used to read the images and modify them. You can do with OpenCV also, but I haven't like, installed this yet, so I'll show with this only. Okay, and from sklearn we'll import two libraries. One is for shuffling this data set, and another is for splitting your splitting your set of data into training and test data. Okay, so now let me run this cell. Now there are two paths. Okay, so path one is your path of input data, where you have kept your data set, so you read that in path one, and path two is the folder where you're going to store your data after pre-processing. Okay, so actually I have given the whole path. You do not give the whole path also because it is in your working directory. And so let me run this, and okay, so now this command listing, what it will do is, from the path one, the folder which we have given in path one, it will read all the files there. So let me run this. Okay, and you can see in variable listing, so listing is 257 files, and you can see those images now they have been read into this variable name listing. So we have bike, we have car, and we should have horses too, horses, and total of 257 samples we have. Okay, now you have read this, you can see number of samples by this command size, so it will show 257. Now from that listing folder we'll read a file one by one, and then we'll open that file using image, and then we'll resize it. Okay, as per we want, and we'll also make them, actually it's a three colored image. You see it's a colored image, and you can see it's a colored image. I will just convert in single channel just to run this code. You can do with three channel also, it's no issue. And then I'll save it in path to this folder. Okay, so let me do it. And before I save it, I just want to show you that the folder which we created for saving is empty. Okay, this is empty. Now once we run that code, all the resized and gray images will be coming in this folder. Okay, so just see, let me run this block of code. And okay, sorry, so I haven't defined here. Actually it's a image row image column, so let me define it, run it here. And it's 200 cross 200. Now let me run this. Okay, so I'll let it run, take some time. Okay, so it's done. Now you can see in that folder input data resized. You see, now we have gray images of size 200 cross 200. So we have done the pre-processing part successfully. Now you can read, now the way we read the files from path 1, we can read it from path 2, which is our new resized data. And we can see it will also have your im list. Now where is the im list? Yeah, it also has 257 files as was the original of listing. Okay, so once we're done with it, and now what we are going to do is we have the input images in this folder. Now we will convert it into array so that we can feed it into our data, or we can do any some mathematical computation in it. So first what you do is you have to open that image. So this is my working directory and my this folder is in working directory, so I need not give the full path. If I wish, I can give full path also. So this image dot open will open one of the image file. So this is the folder name, and this we give path, and im list of 0 means it will read the first file. So this will open the file and it will convert into an array. Okay, so let me run this. And so this code now it would have converted this into an array. And we can see here im1. Okay, so it's a unit 8 200 cross 200 array. Okay, now you can excuse me for that. Now we can also see the number of rows and columns, which we know it's 200, and n will also be 200. Okay, so now suppose if you want to store your entire data set into one matrix so that we can feed it into our network, like in the MNIST set we have the number of rows as the number of images and number of columns, and the columns of each row were the features. So for example, I'll show you here. Suppose I have two images. Okay, and this is one image, this is another image. So this is, there are two images, this one and this one, and they are 3 by 3. So what we are going to do is we're gonna open them up. So that is called flattening of the image. So first image is like this, we'll open it as 1 2 3 4 5 6 7 7, and second image will open it 0 1 2 61 40 32 47, and this one will store it in a matrix. So the matrix which we store, it will have, since I have two samples, it will have two rows, and each rows will be having the pixels of each of the image. So I hope you got this, how we are creating this matrix, and this is what we are going to do with our data set. So as I showed you, there were 257 samples in my data set. So with this code, what I'm going to do is I'm going to open each of the files from this imlist directory, and then I'm going to flatten it like I did here. Just open this image and make it in a one row, and once I flatten it, I'll convert it in array. Okay, and each image is converted into array, and then the entire matrix of the data set will be converted into array. Okay, so let me run this code. And okay, so since our images are of size, you see here, images were of size 3 cross 3, and there were two images, so we got a matrix of 2 rows and 9 columns. Similarly, in our case, we should get a matrix of 257 rows and 400 columns. So you see IM matrix, yeah, it's not 400, sorry, it will be 40,000 because we have an image of 200 cross 200. So each image will have pixels of 40,000, and there are 257 samples, so we'll have this. Okay, so Now once we have stored our data set into a matrix, this will remain here, and now we have to label those data set. We have to give them a class name. So since I'm using three class, I will give a class name of 0, 1, 2. So first you create a, what to say, a label variable which will have as many classes as the number of samples. So let me run this. And okay, so label will be having 257. Yeah, 257 of ones. Now each of this will assign to one class. Okay, now how will we assign to class is we have three classes: bikes, car, and horses. So you go to your mlist folder, mlist or listing, whichever. Now you see how many bikes are there. Bikes are there from 0 to what, 0 to 88. But in Python, when we are giving index, Python won't read the last index. So suppose I give 0 to 100, it will read from 0 to 99. So since our bike is up to what, 88, we'll give the label of 89. Okay, from where the car starts. So I have given label of 0 to 89, means it will read up to 88 is equal to class 0. It means the bike, all the bike images are being assigned as a class of 0. Then I'll go from next this 89 till where the car is there. So I have a car of how many? Yeah, I have 100 cars. Wow, that's interesting. And so we have what, up to 186, but we'll give up to 187 because it won't read the last one. So 89 to 187, I'll assign it class 1 to the car class, and the remaining which is horse class, it will be assigned class 2. So depending on your data set, you can, like, suppose if you're having like 10 classes, then you can go up to 0, 1, 2, 3, up to 9. Okay, so we'll do this. We'll assign the labels to each of the class. uh, so we have assigned a label to our data set. Next, what we are going to do is we are going to shuffle it. So shuffling is recommended because then our data, so our network will learn better way. It won't memorize the data. We saw in our variables that our data are in kind of continuous fashion, all cars, bikes together, then the cars, then the horses. So in order to make our system more stable and make it learn the features very nicely, we'll shuffle it. Okay, so we'll use this command. This is our output data, output label, shuffle. Our data were stored in this IM matrix. So this input will be shuffled, and corresponding to it, the way it is shuffled, the label will also be shuffled. Okay, and this random state is actually it ensures that every time you shuffle in the same manner. If you don't give the random state, what happens is that every time you shuffle, it will shuffle randomly. So if you give a fixed random state, it will shuffle in a kind of a fixed manner. So you can give it anything, 2, 4, 10, anything, it will shuffle in that manner. Okay, so now we have shuffled, and the shuffled data is stored in data, and the shuffled label stored in this capital label. Okay, now we'll store this both data and label into one variable of train data. We'll create a kind of list here. And now since our image is in kind of flatten mode, if you want to visualize it, we can do is reshape. Suppose you take a 167th number of that image and reshape into 200 cross 200. So let me show you. So you see this was a car of 167th, and it is shown here. Actually it's in grayscale, the original image after resizing. So if you plot in gray, it will be seeing like this. So this is what our original image is. Okay, so you can see the shape of your data, which will be, okay, train data. Okay, we haven't called this. Okay, we haven't run this actually. Okay, okay, so now train data is a list, and train data of 0 will be having data, train data of 1 will be having the label. So if you see train data of 0, it will show you 257 cross 4000, that is your data, and this is your label. Train data of 1, it will be 257. Okay, so once we are done with data, reading your data into one variable, now let's define the parameters of the network. So batch size initially we're using 12, but for this this works out. Actually this is what you have to do. You have to change the parameters as per your application and see what works out best for you. And number of classes is 3, number of epochs is 20, image row image columns 200 cross 200, channel is a gray image, so single channel, number of filters 32, pooling size 2 cross 2, convolution 3 cross 3. So let me run this. And okay, so now just for like you can directly use this into your code, or you can assign with some variables, like usually for understanding, for better semantics, so I have given x and y, and x will be having the train data, y will be having the labels. Then this one is what I am going to do is, from the entire data set I will split it into train and test using those train test split command which we imported. So you give the x train, x test means the data of training testing, the label of training testing, then you give the original entire x data and the y data. And here you mention the amount of data you want to split. Suppose I want to split 20% of data, I'll give 0.2. Then again random state, what it does is it will split in the same manner every time if you give any random state. Okay, then this one, since in convolution neural network we feed the images as a 2D structure, I will reshape it into its original form, but it will be reshaped into the number of image samples in the dataset, comma 1 is the number of channel, comma the number of rows, number of columns. Similarly for the x test. Okay, so let me run this first. Let me run this, then let me reshape those images. You remember the matrix which we created was in flattened form, so we reshape it. Now if you see the shape of x train, it will be, it won't be 257 cross 4000 as it was here. Now it will be uh, okay, sorry, this one, let me do this, sorry, yeah. So x train shape will be 205, because actually 257 out of which some has gone into test, and one is a channel, and 200 cross 200. Okay, so and this one actually we are converting for computation, we are converting each of the pixel values in float format, so we'll just convert it float. And this one actually is required to make it converge faster. You just divide it by the maximum value. The maximum value usually is around 255. This you have to do, otherwise your system will be converging very slow. So you do this, then you see the shape of the x train, which is 205 1 200L. Then you can see the number of train samples 205, number of test samples 52, so total of 257 was there. Now this one what it does is, it will actually, you see the y train was 257, means it was kind of a column vector. Now it will convert into a matrix. That matrix will be having, suppose we are having 3 classes, so it will assign one to that position which correspond to the class. I'll show you after running it. So you see here, yeah, this y train. Now since we are having 3 classes, and x train is y train is having 250 samples, so it will have 250 rows and 3 columns. So if the label was 1, so it will become 0 1 0. If the label was 0, it will become 1 0 0. If the label was 2 of the data, it will become 0 0 1. So 1 will be at that position which corresponds to the level of that data. Okay, and you can see that it is shuffled the way means we shuffled with that command. Otherwise the it cars would have been coming here, sorry, the bikes would have been coming here, all one this. Okay, so I think you understood the role of this, and this is actually required for categorical cross entropy function, the loss function. And this is just to see this. Suppose you can see one of the image here. So this is the image, and you can see the label of this image. The label is what, 001. It means it's a class 2 data from class 2. Okay, so now done with this, we'll call our model. The model is same as, I didn't change it as it was used for MNIST. Let me run this. It'll take some time and see how much time it takes. Okay, so now I will run this model.fit and I will train it on x and y train, and I won't split because I have very less amount of training data, only 205. I'll validate it on the x test, y test. So let me run this code. Yeah, and so training will start. You can see I have 20 epochs, and the loss is too much, and you can see the validation accuracy is not improving, the although this is improving. So you see this actually network is not so good, and so this is a challenge. Actually we have to change the parameters. So you can see validation accuracy is not at all improving, so the chances are that it's overfitting. So let me stop this and let me change some of the parameters. So in this case the dropout which are using is 25% and it's highly overfitting, so let me make it 0.5. So once I have changed this model, let me compile this model once again afresh. Okay, so let's see what is the effect of increasing the dropout. Initially you see it wasn't learning, every epoch is 36, 36, 36. So now let me run this. I hope I should get some improvement. Okay, so 38, 34. Okay, it's not improving either. uh, so you see that I was not getting improvement here also in the previous case. So I didn't change anything, just I kept it at 0.5. I compiled it once again, I ran it. So in this case you can see clearly the improvement. The loss is decreasing here. You can see 710 point. Accuracy is improving, the training accuracy. Even the validation loss is decreasing, and the validation accuracy is improving. You can see here. I'll show you. You see this is the validation accuracy and it's kind of improving. So I let it run for 20 epochs, and okay, so I'm done with it. I got a final training loss of 0.0019, training accuracy of 1, validation loss of 0.683, validation accuracy of 0.898293. So actually we have to run this for more epochs. You can see the error will decrease further, and this you have to do as per your application. Just for showing, I have just kept 20 epochs, and now you can check your say, this one, and yeah. So I have got a test accuracy of 0.73 final and a loss of 0.88. So this is not that good, but just for your understanding I have showed it. You have to change few more parameters, make it more robust. So actually what we do is validation and test we keep separate. Whatever we are using this here, we won't use for testing. Your test data will be separate and you will test it finally here. Because of the shortage of data I'm doing it. Okay, so now if you want to predict the class from 1 to 4, so we'll give 4 samples of x test, and let's see what it predicts. It predicts 1011, and let's see the actual value of those labels. So actual value is 1 first case, second is 0 but it's showing 1, so there is one error, and this is 1 and this is 1. So you got the idea of how to like import your data and work on it. And similarly you can visualize the intermediate layers the way I show in previous video. Suppose you want to visualize the same as the previous video, the first convolution layer output, and we'll run this function. We'll see the input image, what input we are feeding it. So okay, let me see this here. Yeah, we are feeding it a car. And you see here input image dot shape is one image, because I'm having just one data and one channel, and it's 200 cross 200. So now let me put this into this output function and see what is the output image shape. So output image shape is 132 198 cross 198. Since we are having 32 filters, for each filters we'll have one image, and the size of image will reduce from 200 to 198. Now let's reshape it to, not reshape it, change the axis to 1 198 32. So now we'll run this block of code, okay, for visualizing those 32 outputs of one of the input image of car. So let me run this, and we should get the 32 feature maps. Okay, so for this car input car, what our system is learning after the first convolution layer is this 32 features. Okay, similarly you can visualize the output of activation layer. It's running this code. Okay, so this is the output of the activation layer corresponding to this convolution layer. So I hope you got an idea of how you can feed your data into your CNN through this procedure. There are other techniques also, by creating your h5 file, or your pkl file and all that, but this is kind of simple and straightforward. So I hope you explored this more, and if you have any doubt you can comment below. So that's all. Try your own data set and train it, and try your own network. Good luck.